in the heart of Colmar, France. One of the most sophisticated excavator manufacturing plants in the world operates with remarkable precision. Here, raw materials undergo a transformation, evolving into powerful, high-tech machines that drive the construction industry. What begins as a simple steel plate will soon become a cutting-edge excavator, thanks to a carefully coordinated production process. From raw steel to precision components, the journey starts with large sheets of steel, which must first be cleaned to remove any rust or impurities. In just 15 seconds, the surface is smoothed and prepped for processing. The steel then moves to a state-of-the-art plasma cutting machine, where a single plate is sliced into nearly 100 individual parts in one swift operation. Plasma cutting is a game changer, using electrically conductive gas to slice through steel plates up to 80 millimeters thick. The temperature at the cutting site soars to a staggering 30,000 degrees Celsius, ensuring extreme precision. Compared to traditional cutting torches, plasma technology is 4 times faster, increasing productivity while maintaining accuracy. A single 20 square meter steel sheet yields around 180 individual components, all prepared in just a matter of minutes, each designated for specific sections of the excavator. Next, the raw steel pieces enter the bending and stamping department. Here, 5,000 tons of steel and stainless steel are processed annually. A variety of techniques, bending, stamping, and rolling, help shape the excavator's complex components. Bending uses a punch and matrix to create precise angles. A rolling shapes steel into rounded forms from mechanical elements. Once shaped, these components make their way to the welding shop. Before welding begins, workers carefully clamp the cut parts of the undercarriage and other key structures. While robotic welders perform the majority of the work, human precision is still essential. If parts are misaligned, even the most advanced machines cannot correct the mistake. With everything secured, the welding process begins. The first step involves placing the slew ring onto the center of the undercarriage. Using flames that reach temperatures of 1,700 degrees Celsius, 32 robotic welders replace the need for 24 human workers, significantly improving speed and consistency. As the undercarriage nears completion, manual welding is required for key structural components, such as the boom and arm of the excavator. These areas demand expert craftsmanship to ensure durability and safety. Once welding is complete, the excavator's undercarriage moves to the paint shop. Before any color is applied, surfaces are meticulously cleaned, and areas that must remain unpainted are masked off. Painting requires both precision and endurance. Workers operate in a 40 degrees Celsius environment, wearing respirators to protect themselves from fumes. The key to an even coat lies in maintaining the correct nozzle distance, 20 to 30 centimeters from the surface. Too close, and the paint becomes too thick. Too far, and the coating ends up too thin, leaving the metal vulnerable to damage. A properly applied coat ensures the excavator withstands harsh conditions. Too thin, and a minor scratch could expose the primer. too thick, and material costs increase unnecessarily. With the painted components ready, the excavator moves into the final assembly stage. The process begins with a 4-ton undercarriage, which is flipped over by a robotic arm. Workers install the idlers for the track system, preparing the excavator for mobility. The tracks come next, each side requiring 49 interlocking links, wrapped around 2 large idlers and 9 smaller rollers. These tracks will later support the full 30-ton weight of the completed excavator. Meanwhile, key hydraulic and mechanical systems are installed in the superstructure. Every 10 minutes, a crucial component is added, including hydraulic pump, generates an oil pressure of 300 bar, enabling the excavator to lift heavy loads effortlessly. A Liebherr diesel engine, a powerful 5-liter unit produced in Switzerland that drives the machine's operations. Operator cabin, equipped with air conditioning, noise insulation, and an all-around view for enhanced safety. Installing the operator's interface. Inside the cabin, the installation of control systems takes place. This high-tech workspace features a black box system, which monitors vital statistics such as engine performance, fuel efficiency, and hydraulic pressure. Positioned directly behind the operator's seat, this device records essential data that helps optimize the machine's efficiency. Once the controls are in place, the cab is mounted onto the excavator's superstructure, signaling the final stretch of assembly. The moment of truth, joining the undercarriage and superstructure. One of the most critical steps in the entire process is the marriage, the moment when the excavator's undercarriage and superstructure are joined together. The assembly lines operate in perfect synchronization. Before connection, workers apply a specialized adhesive to the slew ring, providing an initial grip. With everything set, a crane lifts the massive 12-ton superstructure and carefully lowers it onto the undercarriage. Once in position, bolts are fastened to lock everything in place. However, the excavator is still missing a crucial component, the lifting system. This includes the hydraulic arms and the bucket, essential for the machine's primary function. With the structure complete, workers install the excavator's articulated arm, ensuring that every hydraulic hose is properly connected. These hoses, just 2 centimeters in diameter, must endure extreme pressure while remaining flexible and durable. The final step is attaching the bucket, the excavator's most essential tool. Once secured, the machine is ready for testing. Before the excavator can leave the factory, it must pass rigorous quality checks. In the first test zone, the engine is started for the first time. Every system, from hydraulics to electronics, is meticulously inspected for proper functionality. The most challenging phase of testing lies in the stress tests. These trials push the excavator to its limits, ensuring it can withstand the demands of real-world job sites. Ready for the world. With testing complete, the excavator is finally ready for deployment. The latest Liebherr series Latronic, built with precision and advanced technology, rolls off the production line, a testament to engineering excellence and human expertise.